Here is our trapezoid video for Unit 7. This is a long one. Trapezoid is a very popular quadrilateral. Here's your properties at the top. I'm not going to read them to you, but we're going to go ahead and just jump right in. On numbers 1 through 4 here, these are just trapezoids. They're not isosceles trapezoids. All right. The only thing you can do on regular trapezoids, notice, how do I want you to go ahead and, I'm going to go ahead and tell you what I'm trying to say here, is how to recognize isosceles versus non-isosceles. Well, one way they can come out and just tell you it's isosceles. Another way is they could give you these dashes on the sides like number 7 and number 8. If they give you those marks on the sides, they're trying to tell you they're equal. Or they can come out like number 5 and 6 and just tell you it's isosceles. Okay? So let's take a look at 1 through 4. There's only one thing, one type of math we can do on non-isosceles trapezoids like numbers 1 through 4. And that is between each set of parallel lines, and every one of these have parallel lines marked with those little arrows. On each side, they're going to add up to 180. So those two angles add up to 180. So I would take, to find angle M, I would take 87, or 180 minus 87. And that's going to be 93. Okay, on this side, these two angles add up to 180. So just take 180 minus the 51, and you get 129, and now you have your angles. Sorry, it's not looking like a 9 yet. And that's the same for 2. These two add up to 180. So, and then these two add up to 180. All right, number 3. These are going to add up to 180. So that's your equation. 54 plus 8x plus 6 equals 180. And you would solve that. On number 4, these two angles are going to add up to 180. And how would you find angle R? Is you would plug x back in. They're not equal. They add up to 180. So I could say 12 and 7 make 19x. 3 and negative 13 make negative 10. And I would solve this and then plug x in. So that's moved down to 5 through 8 when we have isosceles trapezoids. Now look at number 5. These are diagonals. Okay? DG, well, we have these pieces are equal. So these are the sides. These are called legs. And then DF is the diagonals. And those two are equal as well. So that's going to be equal to EG. Okay, now, just like the regular trapezoid, these two do add up to 180. But what you have to remember here is that this is like a mirror down the middle. Everything over here is equal to something over here. So now T and U are equal. And W and V are equal. All right, so look at number 7. P and Q are the same. How would I find R and S? That is when across the middle they're equal, but just like on numbers 1 through 4, on each side they add up to 180. So that's where I get S being 68. and then r will be equal to it. My stylus is not cooperating with me. And then 8 is just like number 7. These two are equal, and then these two angles are equal. And each blue and red angle add up to 180. All right, number 9. MP, that's a side or a leg, okay? That's our first one. I'm going to mark that in blue. NO, I'm also going to mark that in blue because they are equal. There's my two equal pieces. And then PN is a diagonal, and MO is a diagonal. So how would you find X? X is on these blue lines. They're equal to each other. I might as well make that blue. The two legs are equal to each other. So here's your equation for X. And the two diagonals are equal to each other. Only if it's isosceles this works. So my Y would be 5y plus 19 equals 12y minus 37. Okay, number 10. ABCDs and isosceles. That tells me these two are equal to each other. That's how you can find X. So this would be your equation to find X. Okay, once you find X, so X would be 5 here. Then you can start plugging it in. Let's see, did I do that right? No, X isn't 5. But it doesn't matter. I solved that wrong real quick. So X isn't 5 here. But no matter what X is, you're going to plug it in to find C, and D should be equal. And then you would say D and A add up to 180. That's how you'd find A, and then A and B are equal. I'm trying to get through this video in a timely manner so it's not too long. All right, JKLM is isosceles trapezoid, find the missing. So these are on the same side together, so these are not equal. They add up to 180. And then you would plug in X to find everything. So this would be 10x minus 33. You don't have to solve it. By now, you should be pretty decent at solving equations, but you might want to write yourself and make some little notes here, whatever you need to help yourself. But these are notes, and make them as nice as you want. You're going to be able to use them. Okay. All right, this is isosceles. This one's a little challenging, but what you got to do is you can do this one of two ways. This is down the middle, so this can come over here, and then X and Y add up to 180. Or, whoops. Oh, man. Sorry, let me just erase that. Or you can say, I'm going to put this over here, and these add up to 180. Either way, your equation is the same. That 10x plus 5 is going to be added to the 6x minus 1 to equal 180. That is how you would get X. And then you'd plug X in to find W and X. So these two are equal, and then Y and Z are the same as well. And 13, how would you do this one? I'm not going to spend a lot of time on this one because it's getting repetitive. These are equal. So I can write my equation. and then plug X in and find what you need. Number 14, this is the same exact idea as one of the ones above. I can put this over here, and those add up to 180. Whoops, they're not equal. They add up to 180. And then find X and plug in. All right, let's talk about the trap. I'm going to have one example here. I think that's all I have left. This is the last problem in the whole packet. I have one example talking about the trapezoid mid-segment theorem, okay? The trapezoid mid-segment theorem. So anytime you have a problem like this, so the middle one, you'll set on one side of the equation, and you're going to double it. Whatever's there, whether it be 5x minus 19 or it be 8. You double the one in the middle. And then on the other side, you add the two parallel lines together. And that is your equation. And that's how you'd solve and then plug X in to find YZ. So another example, and if I went too quick, remember you can pause this and rewind it. So another example, a more simpler example, if I put, I don't know, 10 here, 16 here, and X here, just know that the one in the middle you double. So this is going to be 2 times 10. And you add the top and bottom parallel lines on the other side. So this would be a very simple example of how you would find this. Subtracting 16, X equals 4. Yeah, it doesn't look like a 4, but it does come out to be 4. Just because I just winged the drawing, it doesn't have to be perfect, but that's solved right. Okay, so there's your formula for that trapezoid mid-segment theorem, and the trapezoid video is over.